Sometimes it's like I don't even know how to do stats. When it comes to regression line homework, just feed it to the rats.
Peek! Don't talk such rubbish. All you have to do is just interpret the computer regression output. Look at the constant. It is 12. That is the y-intercept of the regression line. So if our dependent variable was the speed of a dinosaur and our independent variable was its wingspan, in meters, then a dinosaur with a 0 wingspan would be predicted to have a speed of 12 meters per second. Stats! And science! I don't know why I chose to teach like this. Hi guys, welcome to my AP Stats end of year project. I really hope this works. So, I've had a fascination with the obscure bootleg cartoons of Dingo Pictures from Germany, and you may know them from the Yee meme. But did you know that they can help explain regression too?
Why, yes. But even if your homework is hard, it's not done. We need to talk about the standard error. You'll see it next to your constant and your slope. Think of it like this. Your sample slope, that B number we got, is like finding a perfect diamond in a mine.
So, Dad, the standard error tells us how much our sample size is likely to wiggle and jiggle from the true slope of the whole population? It's the average distance your amount of diamonds per mine, the sample slope, would be from the true average amount of diamonds in the land? A smaller standard error means your sample slope is really a precise guess at the true one. A big one? Oh no, your guess must be a little wobbly. Wow, all this talk about diamonds is really making me understand. This is a totally good and not confusing way to teach me about regression. Shut up, Dundee.
So why do we even do all this regression stuff? Because we want to make inference! Oh wait, sorry, I forgot that it's pronounced inference. That means we want to take what we learned about our tiny little sample of dinos and say something smart about all dinosaurs everywhere. Yee!
We're not just interested in whether roaring makes a little group of friends happy. We want to know, does roaring make all dinosaurs in the population happier? This is where inference comes in. It helps us make educated guesses about the big picture using our small picture. It's like finding one giant footprint and inferring there's a big dino out there that ever lived.
Imagine we take 1,000,000 different samples of dinosaurs. Each time we get a slightly different sample slope, right? Because every sample is a little different.
If we plotted all those different sample slopes, they would form a sampling distribution of B. And guess what? If the conditions are met, this distribution looks so stupid.
Waboo! That's not correct. It looks beautiful and bumpy and curvy. In fact, this curve is centered around the true population slope, represented by the beta symbol, and its spread is measured by, you guessed it, the standard error of B. It tells us how much variability we expect in our sample slopes if we keep taking samples. Very important for science!
Is it though? Haha, it's Waboo time. Now if we're gonna make inferences about all the animals there are, we need to check some things. Think of them as rules for safe interference. We call them conditions for regression interference. Is the relationship between your x and y actually straight, or is it all curvy like a noodle after you dropped it? If it's curved, linear regression is not the best. Plot your data. Are the observations independent? After all, most of the animals are so stupid. But the stupid whooshal stupidity affect another animal's stupidity. We need each observation to be separate and not influenced by others. Random sampling helps here.
When you draw your line, the leftovers, the residuals remember, should be roughly normally distributed around that line. Like how you picked your shinning fruits, which should be evenly distributed around your cave, not all piled up in one corner.
The spread of your residuals should be roughly the same all along the regression line. No fanning out. It's like the noise level of your animals. They should be consistent, not getting stupider and louder as they get bigger. So stupid.
So